doing the tool side of things, supporting game designers basically. And I worked there for about a year and a half, during which they got acquired by a larger company, App11, who's more on the marketing side of things and kind of acquiring various mobile game organizations. And I left that job somewhat recently. Yeah, I've worked in a variety of different languages, and I've used programming outside of my jobs in kind of smaller personal projects, like building websites to support the board games that I designed, or like the project that I'm going to present today related to Wordle, which is one of my hobbies right now. I do Wordle every day. And so I was able to use programming to kind of get a better insight into how to play Wordle better and what makes a good guess. And that will make more sense. If you're not familiar with Wordle, we'll go into full details on exactly how it works and all of that. Should I just keep going into the presentation now, or did you?
Well, let's talk a little bit about, because I have a few questions for you. You mentioned that you didn't go into computer after you finished your studies in computer science. You didn't go into it right away.
Yep.
What was the decision-making process around that?
Well, when I was younger, games were the reason I got into computer science in the first place. And so when I was in high school, my school actually offered a intro computer science course, which I took, and I really enjoyed it. But like the whole reason I wanted to do it in the first place was because of my passion for gaming. And then I took another computer science course one summer at Northwestern, also while I was in high school. And that kind of gave me the direction that I wanted of like, I'm going to college and I'm pretty sure I know what I want. And after I got there and I studied, I did some chemistry, I did some biology, some physics, and I realized, no, like computer science is what I want to do. I'm just not sure I want to do it right away. And things were going really well for me in the gaming scene when I graduated, and I kind of felt like computer science would be there. Like I had done the time, I had done the study. Computer science would be there for me when or if the gaming stuff didn't work out. And so I stuck to the thing I was most passionate about at the time, which was continuing to do that. But I was so grateful to my dad for pressuring me to continue to stay in school. I definitely had moments where I was like, I'm just going to drop out and I'm going to do gaming. I don't need this. And like in retrospect, that was about 10 years ago. I'm so glad that I did stay in school because it gave me the opportunity to get my computer science job, which is it's a very cushy position to be in. It's an you're as a computer scientist at a normal-ish tech company, you are extremely valuable. You have an incredibly specialized set of skills and an understanding of how things work that makes you incredibly difficult to replace. And so when you're graduated from school late 20s and you're thinking, I want a stable job where I'm being treated well and I have good perks, like computer science is an amazing place to be, especially if you can find somewhere that is working on something that you're passionate about. And when I was working at the mobile game company, it was a good match for my passion for gaming, but also my interest in computer science, in building things and solving problems.
I also want to take this moment that if we have any attendees in the room that have questions, we do have a Q&A feature that is live. So feel free to utilize that and type in a question. And when we see it pop up in the Q&A box, we can definitely relay it to Kevin. Maybe one more question, unless Ben has a question, is what are some non-professional ways that you're using programming right now?
Right. So I alluded to a little bit, but with my the board game that I designed, I wanted to have some technological support to make playing the game a little bit easier. And basically the way it works is when you start the game, there's a whole bunch of random characters and cards that you can choose and enemy that you can fight. And these things all get randomized, and then you put them together and you have a setup for a specific game. And so I built a website where you could just push a button and it would generate a setup for you. And it wasn't like you could play the game in your browser, but it was a way to do that randomization and get you started. And I also built another website. So the game that I designed, you track the life points of yourself, of the enemies you're fighting against, and there's a couple other like bits of information that you need to track. And so I worked on putting some of that in digital form to make playing the game a little bit easier. And then things that are kind of straddling the line of programming is like recently I've started using, there's a Steam game called Escape Simulator, and it has a built-in editor where you can make your own escape room. And there's a general UI that anybody who's can use a computer can use this UI and build an escape room. But if you want to do things that are more complicated, you have to actually code it in Lua. And so what I've been doing there a bit recently is kind of looking at examples of other things people have programmed in Lua in Escape Simulator, and then coming up with my own take on it. And so one of the rooms that I'm working on right now with my girlfriend is the Lua implementation allows you to put an object in like a pedestal. And if you push the button on the right, it gets bigger. And if you push the button on the left, it gets smaller. And so there's like some puzzles about that. But in order to do that size changing, I had to use Lua and actually do some programming.
We do have a
We
question.
do have a, oh, sorry. I'll jump on it in part because I was kind of I have to be honest, I didn't want to ask this question, but now that we have an attendee who asked the same question, I was thinking about, Kevin, just out of curiosity, were you able to support yourself, or as the question was, make money while you were playing games or in the esports world?
I was, but not very much. I had a salary through the company or the team that I was a part of, which was pretty meager every month. And then I did some streaming, and I actually did quite a bit of coaching of helping other people understand the game that I played better. And when I did well at tournaments, I would make some money there, but it's a really top heavy, hard to break into industry. If your primary goal is making money, don't go into gaming. I did it because I just was so passionate about it. And we lived in Pittsburgh in a fairly cheap part of the area. And so we were able to get by even on the small amount, but it wasn't really a moneymaker, no.
All right, if there's no other further questions, I won't stop you from getting on with the rest of it.
Cool. So I need to share my screen. I'm gonna, host disabled participant screen sharing. And I'm not sure if you're still talking, but you're muted now, Michelle.
I'm wondering if, Ben, you have access to that, because I think it gave.
I can do it now. All right. So is this coming up? I have a slideshow. Yep. Okay. So, actually, we should start with actually playing Wordle. So for those of you who don't know, Wordle is a word game. And the way Wordle works is every day there's a new word, and you are trying to guess what it is. The word is always 5 letters. And when you put in a guess, it's going to give you some information. So if you ever played Mastermind, it's got some elements there. So in this case, what we can see is any letter that's gray, that means it's not in the word at all. If the letter is orange or yellow, that means it's in the word, but it's in the wrong place. And if it was green, so let's say we guessed something like this. Okay, so the E is green. That means it's actually in the word in this location. So you have 6 guesses to guess the word. And if you guess it before your guesses are out, you win. If you don't, then you lose. And of course, the faster you can guess it, the better. And so the whole point of this project that I'm presenting is how can we better understand Wordle, 5-letter words, in order to inform our choice of guesses using programming. So here we go, finding the best words for Wordle. So before I actually get into the programming part of this, I'm going to be focusing more on like high level strategic decisions and understanding of the problem, because the vast majority of programming, I would say like the skill and the time involved is understanding the problem and understanding a solution rather than actually writing the code. And what ends up happening is if you don't understand the problem well, or don't understand how to implement a good solution, you write a whole bunch of code and then it's inefficient or it's buggy or it doesn't actually do the thing that you thought it would do. And then you go back and you rework it. And so whenever I'm approaching a programming problem, I want to get as good of an understanding of it as I can before I actually start writing any code. And then once I do start writing code, I'm trying to iterate quickly and test whatever I'm doing as soon as possible, and kind of iteratively build up a framework. So the first question here is, what makes a guess good? And I'm kind of posing this also, I'm going to answer it, but I'm also posing it to everybody watching of like, if you think of what makes one word better than another word, is blame a good guess? Is stale a good guess? Is zebra a good guess? And the follow-up here is, once you have a sense of like, maybe you're thinking about different words and you're intuitively, you kind of know like, well, zebra is probably not a good guess because Z is not very common. Think about what is a strategy or a way that we could kind of try and determine for a given guess how valuable it is, like how strong it is. And specifically, this is going to be for your first guess, but it kind of applies the whole way through. It's just as you get information, the value of different guesses changes. So we're really focusing right now just on the first guess. Is there a scrolling chat that we have, or is it only the Q&A?
We only have the Q&A, but I anticipate that you can use it for A's, meaning like you can respond if you have a question. So if folks in the attendees area have any thoughts about what makes a good first guess, they can feel free to type it into that Q&A box.
Yeah, that'd be perfect. So I'm going to take just a moment to let people think about that a little bit more. If you have any guesses or you'd like to stimulate, like any thoughts that you have are good because it also helps stimulate some discussion. One of the big parts of being a good programmer or a good engineer is the ability to communicate well. And it's one of the things that I would say my technical skills are not my strongest point when it comes to programming, but my communication and planning help me excel. And especially the type of person who tends to be an engineer, they often aren't as communicative. So working on those skills, I think, is really valuable. Okay, so the letters that are more frequent, those are going to be more valuable because they're going to appear in more words and they're more likely to give you information. So that's kind of the basis that we're going to start off here with this problem. So in order to determine what letters are most frequent, we're going to need a list of words. Intuitively, you might say, okay, E is probably really frequent, but we're programmers. We need to actually get some real data so that we can have a numerical assessment of how frequent E is or how frequent Z is, and then use that to inform our decision-making. So this is like a more interesting part of the problem than I expected. When I did a search for it, there's about 160,000 5-letter words in English. Scrabble only accepts, Scrabble's list of 5-letter words is about 9,000. So you can see already a huge drop off. I'm not exactly sure like where so many words come from that aren't really in our everyday language. But if you have played Scrabble or played with someone who's very good at Scrabble or looked at this list of Scrabble words, a lot of the words feel like, yes, they're technically words. I know they're accepted as words, but they don't really feel like words you would use. And one of the major principles of Wordle and the words that it uses is that every word is something that's relatively common. There's no really obscure words. There's nothing where you're like, I've literally never heard of that before. And so I didn't feel like the Scrabble word list was actually what I wanted either. So what I ended up using.
I was going to ask, if you put in a legitimate word into a Wordle, it will dismiss it and won't give you an attempt. Is that correct?
That's right. If you can't just guess an arbitrary set of letters, it has to be an actual word. I think it probably accepts more than Scrabble does, with the exception of like I don't think it will accept like cusses. I think it has a filter, especially when the New York Times bought it. I think they changed the list of acceptable words a little bit. So Scrabble list felt like too much. And so I did a bunch of searching of how can we find a list that's more appropriate for actually our purposes, because we want something as close to Wordle as possible. And what I discovered is that when Wordle was originally published, the list of all the words that he was planning on using for the next 5 years are actually in the source code on the webpage. And so people posted about that and they made a list. So the list of words that I use is actually the 2,300 words or so that he had decided were appropriate for Wordle. And another big part of programming is kind of understanding the limitations of your approach. In this case, there's probably several thousand words that are legitimate, valid, everyday English words that could definitely be a Wordle word that are not included in my analysis. And the reason for that is it's just hard to find a list that's somewhere between that 2,300 that's in Wordle, but not quite that 9,000 that's in Scrabble. And the other difficulty is you want to find a list that is formatted in a way that's easy to programmatically chop up so that the program you're using can actually understand the data easily. So for example, if it's like the words on a line and then there's a bunch of random text and then there's another word and there's a different amount of random text, that becomes very hard to set up a program that will chop it up so that you can just input that list of words into your program. And so the thing that I found, and I'll show you what that list looks like, actually made it pretty easy. Let's see, I'm actually gonna just grab the list while we're talking about it. So this is the way it's formatted. It's a date, and then a space, and then a 5-letter word. And so what I was able to do is copy and paste this into a text document. And then I just took the last 5 characters of each line. And then I was able to generate a list that I'm using Python for this project. Python would be able to understand. And there was one actual small hiccup here that was quite amusing to me. So I set up the list, and there's so many words here. I just kind of did an initial spot check. I looked at 50 or 100, and I was like, okay, this seems like it's working. And I ran my analysis, and it was telling me that it was detecting blank letters, like a word had a space in it, basically. And I was just like, how is that possible? And what I discovered is that in their list here, they put these 2 lines in to try and discourage people from reposting their list. So you can see that the date is for December 32nd, which obviously isn't a date, and the words are don't and repost. And so this don't, when I was cutting the last 5 characters, was grabbing a space, and that's why my data thought that a space was appearing as a letter. which is just, I don't know. It was kind of silly when it happened. Okay. So we got our list of words. And what we're going to do now is do some data analysis on it. So we want to find out in this list of words, how many times does each letter appear? And we can use that to inform our decision-making towards making a good guess. And this is another point where I thought there was kind of an interesting design decision, which is if a letter contains, let's say, 2 or more E's, should you handle it differently? And if you should handle it differently, how would you handle it differently?
That's interesting because I was thinking when you were asking for feedback on what would be a good first word, that I would try to pick something that didn't have a duplicate letter in there.
Yeah, you can kind of intuitively think like that's probably correct. But you can also think like, let's say E was in 60% of all 5-letter words, something outrageously high. Then like, does that start to change it where you think like maybe 2 E's is the correct guess? And so this decision, like obviously you can go back and change the program later, but you can also think of this like, is there a threshold where suddenly you might want to change how you handle multiple occurrences of a single letter?
That's true. When you were saying that, I was thinking there might be more words with double letters or like double E's than a word that has a U in it.
Oh yeah, and that's a really interesting analysis that you could do. So what letter do you think is the most common? And I'm kind of asking everyone. Since we don't have like a running chat, it's a little weird to share it in the Q&A, but if you just want to think to yourself of like, what letter do you think is the most common? What letter do you think is the least common? I like to do stuff like this ahead of time because it helps inform your intuition a little bit when you start to see the data. And sometimes it can help be like a spot check. So you think about the data and you're like, okay, it's, I don't know, vowels, like maybe A or E, maybe T. And then if you see the data and it's like, you know, T is the second least common, you're like, okay, maybe something's wrong with the program then, because that doesn't seem right. Okay, so we've got a couple guesses. Least common Z, least common X, most common S, most common E. Michelle, do you have a guess?
I was thinking probably the most common would be E. And I think I would pick the least common would be X as well.
Okay. Yeah, I did this, a shorter version of this presentation yesterday, and that was E, X, Z. A couple of people guessed Q. Do you have a guess, Ben? You're muted.
My first thought, of course, was what Michelle said, but I'm going to go with just to mix things up. I'm going to throw A in there as most common.
Okay.
And I don't know. Let's go with V as least common, just to mix things up. V.
All right. Cool. All right. Everybody's had a moment to think about this. So let me see. We'll oops. Actually, before I move on, I'm gonna show the data a little bit since we've all been thinking about least and most common. So move that out of the way. So I have this sorted by total occurrence. Let me hide some columns actually. Hide all these. Those would be for later. So E is the most common at just over 10%. Yeah. +1 to anyone who guessed that. And actually J as the least common letter. Yeah. And of course, keep in mind that this is the smaller list of words. And so there's probably a whole bunch of words that you might be thinking of that aren't included here. One thing that's a little weird too is like Wordle doesn't use plurals. So 4-letter words where you'd add an S to the end to make a plural, those aren't valid Wordle guesses. And so we can see EAROTLIS. This is kind of like our power 8 or 9 or so, and then you start to drop off. But like even if you were to take just the first 5, you're already accounting for 40% of the words. And so an initial heuristic here of like a good word might be, can we make a word that has TORANE? And there might be one. You can use an anagram solver and just put those words in and it will tell you. Okay, back to this. So we've got this big list of words and we're going through and we're counting each letter, but we have to figure out what is a way to print this so that people can actually understand it. And I kind of got ahead of myself by showing the spreadsheet. But you can imagine printing this data as a big chunk, just as text. It's very hard to actually understand and parse what you're looking at. And so one of the things that I did here is I had it print the information as a comma separated list and then saved that as a CSV and then uploaded it to Google Sheets. And so, for example, if you were doing this in production code at a professional work environment, additional steps you might take would be to have it write the data directly to a CSV and then upload that data directly to Google Sheets. And so you could run this and it would just go from a list of words all the way straight to Google Sheets. But for something like a personal project like this, that's totally unnecessary. So the first step I did was just have it print the information and then I had it turn it into this comma separated list. Okay. How would you score a word? If I give you a 5-letter word and I give you that spreadsheet that has all the data there, what is a formula? And I do want some audience participation if anybody has ideas or thoughts about this. How would you assign a numerical value to this word? And we can just use the word stale as our example, STALE. And I'm going to bring up the data again so you can kind of look at that. So these are the ones that we're talking about right now. Oh, that's not very dark. Make it a little darker. Okay. So we've got the frequency that these letters occur. We're not, I don't know if I mentioned this, but with the multiple letter occurrence issue, I chose to just ignore it entirely for like a first simple naive implementation. It seemed simpler that way. And this is another point where it's like knowing the limitations of what you're doing. I understand that this program is probably not handling words that have multiple of the same letter, like greed or creed. And that's okay. We work with what we have. We see how the data fits and we can run tests in the future. And if needed, go back and retrofit it to handle this case a little bit better. Michelle, do you have any thoughts on how you might score?
I was thinking that we could either do it by using the row number. So I think if we add up the rows, I think that would be 28. And then it would be like golf. You'd want to shoot for the lowest number, or you would like invert the numbers so that the top
Right.
most popular one would be, you
So
know, a
we
high
could
number.
sort of, oh, not that way. Sorry.
That was my thinking, but I mean, if the audience has a different way of calculating a score for a word, I'd be down to hear what other folks have to say.
Yeah, and that's actually a totally different approach from anything I had considered. So that's interesting.
You can tell I don't play Wordle every day.
I'm not saying it's bad. It's just the spreadsheet was the very last thing that I did as part of the project. And so the scoring and all of that, I thought about how I was going to do it just from the raw data. Like what you said makes perfect sense when you look at the data in this format, right? You're like, oh, it's nicely sorted. We have a numerical value for everything. Why don't we just use those? Right. So another approach you could use is to use these frequencies. So we can see like S occurs almost 6% of the time, and we could just add these up. So we could say that the value for this word stale is 37. We just take the percent, we multiply it by 100, because or we just call it 37 or whatever, because 37% is 0.37. So you multiply it by 100 to give a more human readable number. And another way you could do this would be to multiply these percents together and then times them by a really big number so that you get something that's like tens or hundreds. Because you could see if you did this times this times this times this times this, it just thinks you have 0% because the number is so small. So we might be able to, there we go. So we could say that the score for this word is 20.3. That would be another approach. And what's interesting about the two that I just said about adding them together or multiplying them is they kind of end up doing the same thing. The difference could be if you're adding all of these numbers together, the variance between good words might be so small that it's kind of hard to reason about. You're like, okay, this word is a 39 and this word is a 38. Maybe they're basically the same. And sometimes when you multiply the numbers together, you get numbers that feel bigger or more different. It's kind of like just a human thing rather than like materially changing the output or how the data functions. Okay, so now we're going to talk about what are things we could do to improve this initial implementation. So what we have right now is our initial Wordle list, the frequency of all of the letters, and then some scoring and analysis using that frequency. So what are other things we could do to improve a guess? For example, stale and least use the exact same set of 5 letters. But are they equivalent guesses? I see you. Yeah, I see you have something to say. So please share.
I'm not really sure. I mean, I think according to my scoring, now I'm like revamping that because I feel like least would be ironically more used than stale in everyday conversation, and that would probably trigger people's psyche of like, oh yeah, that seems to be probably, since it's a higher frequency of word use, it would be the also greater frequency of popping into folks' heads. Mm-hmm. So that totally changes the scoring system.
Right. And you can also see very clearly that the data we've gathered so far has no way to account for that. And so one of the major improvements then is clearly a letter in a specific position has a different value. If, for example, E predominantly appears as the last character in a word, then an E anywhere else is less valuable. So in that case, stale would be significantly better than least.
But that would go counter to the frequency argument I just made.
Yes. And that's kind of alluding back to what I was saying earlier of like iteratively improving on solving a problem is much easier than trying to think about every possible situation that could come up. When I design this program and when I do programming in general, I always try and consider what might I want to do so that I can design it in a way that it's extendable and I can modify it easily. But also, I'm not going to try and solve that out there problem right away. I just want to leave the option open so that I could in the future. And so what I did with this one is I started by just generating that frequency, but I already had an idea in my head that like this wasn't going to be sufficient. Okay, so I'm going to show those columns that I hid, which if you were eagle-eyed, you might have noticed that this is the data that I was just alluding to. So what we are looking here, I'm going to sort it this way because it makes more sense to me. Take away these. For each of these letters, we still have the total number of times that letter occurs. And then we have the number of times that that letter occurs as the first letter in a word, second letter in the word, third, fourth, fifth. Next to that, we have the percent of the total occurrences. And the cells that are highlighted green, I just set this up using conditional formatting in Google Sheets, are ones where the percent that it appears is exceptionally high, so much so that you might consider that letter being in any other position to be kind of a bad or a wasted guess. And so you can see not every letter has a green cell. Like for example, L actually is fairly evenly distributed. Second is the most, but not as extremely the most as say E, which is almost 34% as the last character. And so now with this data, we can definitely say, we have the information we need to say between stale and least, one of these is probably better than the other. And it mostly comes down to, well, if we just do a quick eyeball check here, let's do with stale. So S in the first position, that's an excellent guess. You can see 55% of the time, S appears first. And then T in the second position, not so good, only 10%. A in the third position, 15%, it's okay. And then L in the fourth position, 22%, that's pretty good. And then we have E in its best position. So S and E are in their absolute best positions. S overwhelmingly is much better first. And then you can kind of do the same thing with least to do like that eyeball check before you maybe go through and actually set up a score so that when you start to score things, you think, okay, let's start with something that I kind of intuitively understand. And that helps you debug your program a little bit easier. If like the first time you run it, you kind of have an expectation of what the outcome should be. Are you surprised by any of these positions? I know there's quite a lot of data here, but I feel like with the green cells, you can kind of hone in on certain notable parts.
Maybe Y in the second position. I think
that it even occurs that many times. Yeah, seems a little surprising actually. And so one of the, like an interesting improvement you could do would be to be able to specify a letter and a position and have it just show you all the words where that's true. And that could be like an interesting way to kind of narrow down a list. You could say, okay, let's start with all the words where E is last. I mean, that's 420 words, so that's quite a few. And then you could maybe say, okay, and then show me all the words where A is second from that already limited list. And you could use that to kind of go from this big list to something smaller until maybe you end up with only 3 or 4 or 5 or 10 words left. And you're like, okay, these are probably some of the best guesses I could make.
Actually, it's my bad. I thought it was Y, but it's U that was used 186 times. And I was like, but even so, that's
Oh,
I
yeah.
can't put that many words. U in the second position.
Right. I think these are mostly words that end in Y. This is like bumpy, puppy, mummy, pretty curry. There's quite a lot of words with that
Now you're
specific
listing them,
construction.
and I'm like, why didn't I think of that?
Right. Yeah, the one that really sticks out is Y. 85% is the last character, which also means, and this is like another interesting take here, if you guess a word that has a Y last and the Y isn't there, there's actually not that many words it could be. Right. You're getting so much negative information. Like there's only about 50 words that are left. And presumably your word that has a Y at the end has other letters in it, which would narrow that list of 50 down even more. And so you're probably only left with 3 or 4 or 5 words or 10 words or something that it could even be. And so like part of this project was to build something that you could score a word, but part of it is also gathering data so that you can gain a better intuition about just reasoning about the game in general. And then you can use this data, as we were just talking, to like maybe extend the tool to do something that you didn't even think you didn't realize you wanted to do until you generated the data and saw what it looked like. Cool. Let's see. So I have just a little bit more instruction, and then I'm going to open up the program and we're actually going to guess words and see what they score. So just a couple of guidelines. Getting into programming can feel really intimidating. It can feel like there's too many things to do and it's overwhelming, but you can follow some simple guidelines that will get you started. And once you're started, it's a lot easier to keep going. So always test often. And that's from the very beginning. Like if you're setting up a workspace for the first time on a new computer, or you've never coded in a language before, your first test is literally a program that runs and does anything at all. And that actually, it sounds stupid, but it's actually a huge milestone of like, I set up my work computer, I'm coding in Lua, and I got it to print hi. And that there's like a classic programming thing. If you make a program that prints hello world, and there's a reason that it's so iconic, is like all of a sudden now all the little pieces fell into place. Okay, I can do something now. I've mentioned this a few times during the talk, but focus on solving a simple self-contained case before trying to solve the whole problem, and try to design your code in a way that it's extendable. If you can't design your code in a way that's extendable, or you don't know how to do that, just try not to waste very much time getting to that early solution. It's like the code doesn't need to be pretty. It doesn't need to be particularly efficient for your first run. You just need to get to something that generates some kind of simple result, some kind of milestone that will help you better understand the problem, and then you can go back and clean it up later. But you don't, I mean, it doesn't mean design code that's unreadable. It just means don't spend 10 minutes fixing something up that you might not even end up using. And then the other part here is like when something goes wrong with your program, if you've been testing it incrementally, and then you just added 20 lines and you try and test it and it doesn't work, well, you know that the 20 lines you just added are the problem. Versus if you write 150 lines and then you try and test it and it doesn't work, figuring out what's wrong is so much more difficult. And so these guidelines are like just a way to make your life easier, especially as you're getting into programming and everything will feel unfamiliar and uncomfortable. But if you stick to test early, test often, focus on simple cases, your introduction and eventual projects should be a lot easier to get through. Okay, and then I'll make this available for everyone. There's a GitHub with the code that I use to generate the data as well as the scoring. There's a link to the Google Sheets data, so if you want to take a look at that yourself. And then I have my email here. If you have any questions, feel free to reach out. Okay, and now we're going to do some guessing words and scoring. So I think this is set up right. Let's see. Which one are we scoring with? I have it set up. Okay, we're going to score where it uses positional data. So any words you want to see the score of, go ahead and put them in the chat. We're going to start by just doing least and stale since we were, oh, I need to share a different screen, I think. Let's see. This. You can see the Python now, right? Yeah, okay, perfect. So we'll start with these two. And you can see that stale actually scores significantly higher than least, largely because E and S being in their correct places. And the way that I'm doing the scoring, yeah, if you have any words you want to score, please put them in the chat. Or Michelle, if you have any you're curious about, let me know.
I was trying to look at all the green position letters and make word out of it didn't make any sense. How about spare? S-P-A-R-E. You know, it's kind of a take on the stale.
Yeah.
That is good.
Yeah, you definitely better than least. And I think that's again the S and the E being in the right place.
Yeah. I was just, oh yeah, that the R in there would help, but maybe not.
Yeah. And so the way this scoring is working is it's kind of what I was saying before, where it's just taking the it's taking the percent that letter appears in a specific spot, multiplying it by the total occurrence of that letter, and then multiplying all of that by just a gigantic number. I believe so. I should have left a comment for myself with exactly what the code was doing. It's yeah. So any other words people would like to score or are curious about? Put a couple in here. Some weird words. Yeah, abyss is a real. There's a couple here that are like, when these come up in Wordle, they're really, really hard to guess. And I think that's like another interesting heuristic here you can see is like, Usher is extremely unusual with its positioning. Right. The U being first and then the whole thing. And so you can say like, okay, if a word is really low scoring, then that means it has a pretty unique construction. And so often you can get clues about it. Like if, we looked at the data for U and it was overwhelmingly in the second or third position. So if you have a word that has a U and it doesn't have it in those two positions, maybe it's Usher, right?
I was thinking rhythm has no vowels.
Rhythm is 6 letters.
You're right.
But there is time, which is similar. There's also lymph.
Yeah, those are certainly not ones that like landed at top of mind.
Right.
I was going to ask though, I don't know if, because you used a set list of data, if eventually there could be some moments of, kind of iterations of the program based on user feedback, right? So every time there's a round of Wordle that's played on New York Times, that would give you a lot of inputs of what people tend to start with.
And then using that to kind of inform you. Yeah, potentially. There are like, one disclaimer about this is nothing I'm doing here is like revolutionary. You can just search for websites that will give you scores for words. But there is something cool about doing it yourself, understanding how the code works, which also means you can modify it however you want. Like some of the extensions that we talk about are things that are not particularly hard to do once you have the base code. And with some of those websites where you'd find it, it's not so easy to extend someone else's code that's been embedded in a website and so forth. You know, sometimes the GitHub will be available and you can download the source code pretty easily and work on it, and sometimes you can't. I'm gonna run it here. So I'm gonna show you a little bit of the raw output. What I did is I set the code up so you can pass in a flag, either true or false. And if it's set to true, it will print some debugging information. And so we can see here, this is basically the format that I'm printing this in. I can copy and paste that right into a CSV, and it will be able to be uploaded. And this is more what the data actually looks like. It's a table of a table. And so in this big table, I know this is very hard to parse. But basically we can see C is an entry in the big table, and keyed to C is a smaller table. And this smaller table, the first value is how many times that letter appears. And then the next 5 values are how many times it appears in each position. And then the final value is the total time, the total percent that it appears overall. So you can see that C appears about 4.1%. And the reason I'm showing this is because as you are designing a program, having print statements like this that you can easily turn on and off is very helpful, because when something breaks, it's much easier to print this where it says, you know, C is appearing 10,000 times. And you're like, well, that can't be right. Clearly something's wrong, versus just reading the code and trying to intuit about it. Cool. I don't really have much more to present or talk about. I'm happy to take questions for the last couple of minutes. You know, we can wait a minute or two, and if there's no questions, then we can just call it there.
Yeah, we certainly welcome questions. I know Ben apologized. He had to hop off. I think he got kicked out of the office building, so he needed to leave. But I do appreciate, and we can wait for some of the Q&A to come in if there are any. But certainly it's been revolutionary for me, you know, just being able to understand the capacity of what you can do to explore, you know, a very fun game and kind of deal with the analytics of it. So really appreciate your time this evening. We have, you know, this is a new piece that we're adding on to the Hour of Code. So I appreciate you being part of it. We are recording, and I'll actually stop recording right now.
Sure.